Hello, I'm Zach. Today we are going to talk about Chapter 8 of Eloquent JavaScript, Bugs and Errors Handling. This chapter is all about debugging. Debugging is the process of finding mistakes, aka bugs, in programs. By the way, do you know why we call mistakes and errors in a program bugs? As I know, when computers were first invented, they were huge mainframe computers which took up a whole room. And when they were running, it's very hot in the room, and there were some actual bugs growing in those machines and eventually causing some errors. So from then on, people call computer mistakes or errors bugs. And in this chapter, we are going to cover 6 topics. The first one is a strict mode. It's a special mode you can set in JavaScript so that you have to be more careful about the using of the syntax, etc. And then we will talk about how to write some testing code to test your functions. Next, we will move to debugging. And so when you encounter a mistakes, how would you find it out, like where it happens? And next, we will talk about how to handle invalid inputs. And the most important topic in this chapter is the exceptions, and which is handled by the try-catch finally blocks. And finally, we have assertions. Assertions are used to check certain conditions, and if they are not met, you can stop the whole program. Okay. Here we go. Strict mode. You can implement strict mode by putting use strict with the double quotation mark at the top of a file or a function, and then the program JavaScript will check the syntax more strictly. Here is an example. We have a function called can you spot the problem, and we put use strict at the beginning of the function, and we have just one for loop in the function. Can you see what's wrong with the program, with the function? Actually, there should be a var here, but it's missing. So in normal mode, this is not a problem. But when you use strict mode, there will be a warning, and you can fix it, and so that you won't cause something unexpected. And then another thing that strict mode change is the binding of this. Here is an example. We have a use strict at the beginning of the file, so it affects all the functions in that file. So we have a function called person, and it just set up the name for the person. And here we create a new person, but we forgot to use the new keyword here. So it won't create a new instance for the for the object. So this will refer to nothing. Therefore, you got a type error because this is undefined. So you can access the property of an undefined object. Okay, so in strict mode, this will be an error. And some other rules in strict mode are, firstly, it disallows giving a function multiple parameters with the same name. Actually, it makes sense. Why would you give the same name to different parameters? It also removes some certain problematic language features, such as the with statement. Since it's problematic, we are not going to cover it. Just in strict mode, they are not available anymore. So in short, putting a use strict at the top of your program rarely hurts, and it might help you spot a problem. Therefore, it is recommended. Okay, testing. So we have a function here, and we want to know if it's working as we wanted. So we write a testing vector function to test this vector. In this function, we just set up the x and y values, and then implement a plus operation. So we create two vectors in the text vector function and do a plus operation and check every variable to make sure everything is okay. If any one of them didn't end up correctly, we return a fail. And that's how you test your code. And there are many testing frameworks for JavaScript you can use, but that will be a different topics. If you are interested, you can Google testing framework for JavaScript. You will find a lot. And debugging. So when you encounter an error, how do you, and you are not sure where it happens, you can use console log to print out the variables and the context of the program so that you have more information for the error. Another thing you can do is to set a breakpoint. So it's like you want the program to stop at a certain line. You can set a breakpoint at that line in your browser. Yes, because most JavaScript is run mostly in a browser. So you can set a breakpoint in your browser. And another thing is the debugger statement. It's similar to breakpoint, but you can use it in your code rather than in your browser. Usually, you want to use console log because it's easiest to do. And then when you receive some inputs from your user, you should check their inputs. Sometimes they would enter something you don't want, or it's not what you are expected. So, and there are three things you can do with invalid inputs. First, you can ask again, or you can fill in a default value, and finally you can return a special value to let the caller or your user know there is something wrong, and you can use null or undefined for that special value. And exceptions. So when your program cannot proceed normally, you should stop the program and jump to a place where it knows how to handle the problem. Exceptions are a mechanism that make it possible for code that runs into a problem to throw an exception, which is simply a value. And when you throw an exception, the program will stop and jump out of the current function and its callers until it reaches the bottom of the stack or it is caught. So let's take a look at a real example. Here we have a prompt direction function which will prompt for direction, and if we got input of left, we return left L, and if we got a right, we return R, which means we only take left and right as the valid input. If we got something else, we throw a new error with this as the message, and result is the result we got from the prompt, right? So error is just a new object, a special type of object which contain a message and some other things, and you can throw it, and when you throw it, it's an exception, so it will jump out of this function. And let's see where the function prompt direction is used. The function look here, the function prompt direction is used here, and ask for direction and return a horse if the answer is left, and return two angry bears if the answer is right. So let's take a look at where the function look is used here. Okay, here we got a try and catch block, try block, catch block. Okay, in the try block, we will try to run this line, and you can we will go into the look function and then the prompt direction function. If there is something wrong, an error, an exception will be thrown, and then the program will jump out of this function where the exception was thrown, and then it will jump out of this function to the caller of the prompt direction function, and finally it will be catch by this block, and it is already the top stack of the program. So, and the error will be stored in this parameter. And inside of the catch block, you can deal with the error. Here we just console log the error. Yep, that's how you throw an exception, try and catch an exception. Okay, and the error constructor. So we talk about the error here. We created a new error here and throw it as an exception. Usually, the error has two important properties. The first one is the message, and the other one is the stack. The message is the error message, and the stack contains the scope where the error occurs, so that you know which stack the error happens. And finally, we have the finally block. This block will be run no matter what happens. And here is an example. We have a context here, and inside of this function, we store the old context. And after running the program, we restore the context to the old context. So if we want to throw an exception within the body function, we can do it like this. So we store the old context and use the new context as the context, and we try to run the body. If there is nothing happen, like there is no exception, this line in the finally block will still be run, which means the old context will be restored. And even there is an exception, this line will also be run, which also means the old context will be restored. So no matter what happens, the old context will be restored. And here we have to store the result before we return it, because we have to do the restoring. But here we can restore the result of the party function right away, because even if it is returned, this line will still be executed. And the next thing is you can define your own type of error. Why would you want to do that? Because the catch block will catch all exceptions, which means you will catch something that might not be what you are expecting. So we can define a new type of error and then use instance of to identify it, to make sure we are catching something that's what we want. Here is an example. We create an input error. That's a new error. So we store the message, and then remember the stack we talked about in the error constructor here. So we store the stack of the error as well. Okay, and we use error prototype to create as the prototype of our new error type, and we set the name of the prototype as input error. Okay, here is how you use it. We have the same prompt direction function here, and we throw a new input error. That's the one we created, and this is a for loop with nothing in the parentheses. The for loop will run forever. So we need a break to break out of the loop. So in this try and catch block, we catch the error and check if it's an input error. If it's an input error, we will console log not a valid direction, try again. And if it's something else, we just throw the error and to allow another catch block to catch it. Okay, finally we have assertion. Assertions are a way to make sure mistakes cause failures at the point of the mistake, rather than silently producing nonsense values that may go on to cause trouble in unrelated parts of the system. So you use assertion to check a certain condition. If they are not met, it's not met, you throw an exception so that the program will stop and deal with the error. Here is an example. We have an assertion failed error. As usual, we store the message, and then it's a error prototype, and here is the main function. It's called last element, which will return the last element of an array. So here is how it works. And before we do that, we have to check the array is not empty. So the length of the array should be larger than 0, right? So here is our assert function. We have a text and a message. So if the text failed, we will throw an error, an exception. They are basically the same thing, right? With the message we pass in. So here we assert that the length of the array should be larger than 0. And if it fails, like we reach an empty array, a new assertion failed error will be thrown, and the message is the empty array. Yeah, that's how you use an assertion. Let's review what we have learned today. First, we have the strict mode. You can implement strict mode by putting use strict with the double quotation mark at the beginning of your program or a function. And then you can write some testing code to test your functions. For finding out the mistakes, the errors, you can use console log or breakpoints or even the debugger statements. And you should always handle the invalid inputs actively. You should either ask again or prompt your user with an error message. And you can use assertions to throw an error when there is a mistake, and which means the conditions are not met in the assertion test. And finally, we have exception. There are 3 things you should remember about exception. First, you can throw an error, right? And then you can use try, catch, and finally blocks to handle the exception. Finally, you can create your own error type and use instance of to identify it. And that's all for today. Thanks for watching. Next chapter will be about regular expressions. Thanks again. Bye.